Alrighty, guys, we have done it. We have reached the last lesson for Unit 1. After this, you'll have a study guide that you could do, and then the test, and then we'll be done for Christmas. And then hopefully we'll come back in the new year, and uh, maybe we'll be in person, or maybe we won't. I don't know. We'll see how it goes. But anyway, so today's lesson is about distance and midpoint formulas. And before we get into those, we're going to start with a review of the coordinate plane. And before I get into that, I want to apologize in advance because this video might be a little bit longer. For a couple of reasons. Number one, I'm doing some extra stuff with you all because you all are in honors class that I may not necessarily show a regular class. And along with that, I believe it's important that for kids, when I introduce a new formula or something, that I try and take the time to prove where it comes from. And so I'm going to do that in this video. I'm going to show you where these formulas come from and then how we apply them. Okay? Knowing where they come from is not necessarily something you're going to be tested on. Obviously, I'm going to test you on how you can use it. But I think it's valid to show you where it comes from just so you can appreciate it. So anyway, that's my spiel. Let's get into this. So let's start with the coordinate plane. Now, hopefully, everything I say about the coordinate plane is review. You should know all this by now. But in case you don't, we're going to add it in here. So coordinate plane is where we have, it's kind of like two number lines if you think about it. You got a number line running horizontally and a number line running vertically. And when that happens, we have the Cartesian, that's another word for it, Cartesian plane, after Rene Descartes, or the coordinate plane. And so everything in here is an ordered pair. And so let's talk about what we have here. So right here at the center, we have what's called the origin. And his coordinates are 0, 0. Okay, it's in the middle. We start there. And then obviously we have right here the x-axis. The x-axis runs horizontally. The y-axis, which runs vertically. And then we have these four sections, or what we call quadrants. So this one is quadrant 1, and we label that with, that is horrible looking. Hang on just a minute. That was horrible. Trying to use these grids to make them pretty. All right, so quadrant 1 starts right there. And then to find the other ones, we go, it's actually counterclockwise. Okay, so the next one is over here, and this is quadrant, let me do it this way. Quadrant 2. Then we come down. Then we have quadrant 3. And then finally we have, try to do this like fancy. And then lastly we have quadrant 4. Okay, or signified for, I've got a gnat flying around. Sorry about that random comment. Anyway, so 1, 2, 3, and 4. Now let's talk about how the points look in quadrant 1. So everybody in quadrant 1, everybody's positive. So I like to write like this: positive, comma, positive. Everybody's positive in quadrant 1. Good place to work. We come to quadrant 2. To get to quadrant 2, you actually have to start going left on the x-axis and then going up on the y-axis. So going left means our x's are negative and our y's are positive. All right, and then we switch to quadrant 3. So to get here, you have to go left on the x and down on the y. So at that point, everybody's negative. And then we come to quadrant 4. We go right on the x-axis, down on the y, which means our x's are now positive, but our y's are negative. All right. Now, let's talk about distance formula. So we've done distance a little bit, measuring a segment. So remember when we did the ruler postulate, we laid the number line like on one, or the segment on one number line. We kind of just counted the distance between the two numbers. You can do that in the coordinate plane, like your segment would be either a horizontal segment or a vertical segment, in which case you could just count. But how often am I going to give you a horizontal or vertical segment to measure? Not very often. Especially when we're in the coordinate plane. That's why we use this formula. This will tell you the distance between any 2 points on the coordinate plane. So I'm going to try and prove this informally using 2 random points. So let's just put one here. And let's put one here. All right. Let's do a label. Let's say A and B. And just to help us with this, I'm going to write out where we're at. So A is at 1, 2, 3, 1, 2, 3, 4, 5. Let's see, that's right. 1, 2, 3, 1, 2, 3, 4, 5. Yeah. So -3, 7. B is at 1, 2, 3, 4, 5. 1, 2, 3. So 5, 3. 1, 2, 3, 4, 5. Yeah. Sorry, I'm just double checking. Right. So what we're going to do is, now obviously the distance would be, we would just like kind of walk down this line and measure how long it is, but there's kind of a roundabout way to do it. You could go down into your eye level with B and then come over. So what I'm going to do is I'm going to draw that in. Kind of like that. All right. Okay, what I've kind of done is made a right triangle. Okay? And hopefully you remember from middle school what I'm getting ready to do. So I want to find this side of the triangle, if you will. But I can find these really easily because they're horizontal and vertical. I can easily count them. So let's find how long this side is first. I want to start here. So right here is where we stopped. So we'll go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this side right here is 8 long. And then 1, 2, 3, this one, 1, 2, 3, 4, 1, 2, yeah, 4. It's 4 long. So what we would do is, to find this side, we would use Pythagorean theorem, right? A squared plus B squared equals C squared, or A squared plus B, you know what I'm saying. So we're going to do that. We're going to say 8 squared plus 4 squared equals, we'll call that C squared because we don't know what that is. All right, and then we would find out what these are. So 64 plus 16 equals C squared. That's 80. And then because I want to find what C is, we have to take the square root, right, because there's a square on it. So we would say that C is the square root of 80. Now I'm going to stop there because obviously you could do the decimal version of it, or you could do the simplifying a radical with a factor tree. You could do it that way, but that's not pertinent to what we're doing right now. So we're going to say right here, this length was the square root of 80. Now I'm going to finagle this a little bit to show you what I'm doing, or to show you where the distance formula comes from. All right. So this horizontal distance we said was 8. Right? We just found that. So which axis is corresponding with the horizontal section? So in other words, which axis is horizontal? Well, that would be this x-axis right here. And so what I want you to see is where can we get this 8 at using our coordinates right here? Well, if you play around on the calculator a little bit using negatives, you should notice that 5 subtract negative 3 is 8. So I'm going to write that. Yeah, down here. Hopefully you can see it. If not, I'll fix it. So 5 subtract negative 3. I'm going to write it like this. That is going to give us the 8 that we had, right? So what we could have done is I could have kind of, this line I'm writing, I could have stuck it in front of this. But anyway, I'm getting ahead of myself. All right, now, plus, where's the 4 come from? Well, 4 was this distance. It's vertical, which corresponds to the y values. So let's look at our y values. 7 and 3. How could I use that to get the 4? So we sit and think for a minute. Hopefully it comes to us really quickly. That 7 subtract 3 would get us the 4 that we had. All right. Now, instead of writing the C, I'm going to change it out for D because we're talking about distance, right? So I changed out D, so C for D, I put D for distance because we're talking about. And so what we could have done is this line that I've written here could have went before this line, right? Okay. So instead of reevaluating all this, what I'm going to do is I want to go ahead and find what D is, right? I want D by itself. So I'm going to take the square root. So let me scoot this out a little bit. Oh, no, pull it up a little bit. There we go. So our D, we would write like this. 5 subtract negative 3 squared plus 7 subtract 3 squared x square root. I know that's ugly, but that is technically what we've done here. Right here with Pythagorean theorem, we've just simplified everything. This is how you're more likely going to do it. This is the distance for this. Okay? You subtract the x coordinates, and then those in parentheses and they're squared, and you add it with the 2 y coordinates subtracted, and then they're squared. Okay? Now, as far as working it out, it does not matter which order you put these in because you still get the same answer. And so, in general, what we would say is, because we don't know exactly what these coordinates are every time, this is your formula. And our big square root back. You subtract the x coordinates, generally starting with the second one. That's what that little 2 means. And then adding it with the same thing with the y coordinates. You subtract the two y coordinates, generally starting with the second one, and then they're squared. That is the distance formula. Okay, and I cannot tell you how imperative it is that you learn this formula and try and memorize it, because it's going to come up a lot in geometry because we use it to prove things later on. It's super important. So please try and memorize this. Now, I know that took a while, but I was making sure to prove that formula that you know where it comes from. All right, let's use it. So find the distance between the point D, which is at 5, 2, and E at -2, -1, to the nearest 10th, right? That's your clue that I need the decimal answer, okay? So let's write this out. So put the distance. Start it out. Now, I'm not going to write the formula out every time. I'm not even going to write it out here. I'm actually going to start plugging stuff in. But remember, you can't see it. Well, let me just confuse you all. I'm so sorry. We're using this. Okay. So we generally start with the second x value. So that's I start with the second point given. So -2. Always subtract, no matter what. Subtract the first x squared plus. Then we go back to the second y value. -1 subtract 2 squared. Okay, that's how you set it up every time. x2 subtract x1 all squared plus y2 subtract y1 all squared. Now, as far as evaluating this, here's the process I want you to do. First thing I want you to do is to put your square root back. Now, because we have these wonderful inventions called graphing calculators, you are going to type everything underneath this square root into the calculator. Okay? Don't even worry about doing it by hand. Just type it all in the calculator. So -2 minus 5, if I get that in there, squared, plus -1 subtract 2 squared. Notice I did not put the square root on it. I want you to do it without the square root. Get in the habit of that. And I get 58. So all that underneath simplifies to 58. Now, because this question is asking for us for the nearest 10th, that's the clue we need the decimal version. So what you do now is you type the square root of 58 into the calculator and see what decimal we get. And nearest 10th means we go to the first decimal place, so I'm going to look to the right. That's a 1, so it's not going to round up. And so we say that the distance is approximately 7.6. That's how long that segment would be. Okay, let's do another one. Find the distance between J, which is at 1, -3, and T, which is at -4, 4. Notice it says nothing about the nearest 10th. Okay, this is what I was talking about earlier, that is special for honors kids. You all have had experience with simplifying square roots from honors data and measurement. I am expecting you to use that here because it says nothing about the 10th. So that's your clue that we want the radical answer left, right? And I'll show you how I do that. So let's start writing out the formula. All right. Always start with this. I start with the second one. You don't have to. I just start with the second one because that's what the formula says, but you don't have to. You could start up here. All right. x2 subtract x1 squared plus y2 subtract y1. I need to raise my square root up a little bit, so excuse me while I erase this and adjust it. Okay. So again, x2 subtract x1 all squared plus y2 subtract y1 all squared. If you want to go ahead and make this minus minus a plus, you can. I'm not going to because the way I'm showing you all, we just type it on the calculator. All right, so let's type all that in. Without the square root, so negative 4, subtract 1 squared plus 4 subtract negative 3 squared. So underneath the square root, we should get the 74. Yeah, 74. Now, because we said nothing about the decimals, I need you to simplify this square root if you can. All right? So what we're going to do is I'm going to come over here and do 74. We're going to do a factor tree. So obviously 74 divide 2. That's even, so 2 times 37 gets us to 74. And remember, you have to keep going till you run out of composite numbers. So 2 is prime, and coincidentally 37 is also prime. So we can't go any farther. All right? Now, as far as the square root practice, what we have to do is we have to do this factor tree all we can, and then we look for pairs of primes. Remember? We have no pairs here. And so we say that this square root is as simplified as it gets. So that's where we would stop. Okay? Now, I do have some problems on your homework that some are decimals and some are the square roots. If you run into trouble with square roots, please let me know and I will help you. Okay, that's all distance. Let's transition to midpoint. Now, again, I'm going to prove it, and then we'll do some examples with it. Hopefully this proof doesn't take as long. I did talk a lot for the first one, but anyway. As far as the proof, I'm going to use the same example we used for distance. So let me write that out again. So point A was at negative 3, 7. B was at 5, 3. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. That's point A. 1, 2, 3, 4, 5, 1, 2, 3. There's point B. Draw it in. Okay. Now, again, I'm also going to draw that invisible triangle in. So let me get that drawn in. All right. And then it's a right triangle again. So midpoint, remember, is the point that's in the middle of the segment. So we're trying to find the middle of this diagonal segment. It's hard to do because we can't count, remember? We found its distance earlier. Remember, the distance was square root of 80. Well, I don't want to divide that in half and try and count because you're going to get it all screwed up. So here's why this formula is handy and where it comes from. We're going to call right here, this intersection point, we're going to call it C. than it is with triangle, that corner. What I want to do is I want to find the actual midpoints of these dashed segments. And because they're horizontal and vertical, I can easily find the midpoints. So the midpoint of A to C, how long is AC? 1, 2, 3, 4. It's 4 long. So half would be 2. For the midpoint. So I'm going to put the midpoint right there. That's the midpoint of AC. What's the midpoint of BC? Well, how long is that? 1, 2, 3, 4, 5, 6, 7, 8. It's 8 long, so 1, 2, 3, 4 is halfway. Okay. Now what I'm going to do is I'm going to draw lines that run through the midpoints of both of these. So this one we're going to draw a horizontal line through it, and this one we're going to draw a vertical line through it. And that should tell us where the midpoint of AB lies at. So let's do that. Let's draw a horizontal one through here. Let's draw a vertical one through here. Oops, that's not straight. And so wherever those intersect is supposed to be my midpoint. So they intersect right here. Let's call that M for midpoint. Where's M at? Let's find where M is at. M is at 1, 1, 2, 3, 4, 5. So 1, 5. Now, I want to try and show you where this is coming from. Remember, midpoint is in the middle. And sometimes when you think of middle, you kind of think of like average, because average tells you what's in between two numbers, right? The middle between the two. So let me show you. Let's do the average between these two coordinates. Okay, so -3 plus 5, and there's 2 of them, so we divide by 2. 7 plus 3, divide 2. The average of those coordinates. So let's look at that. -3 plus 5, that's 2, divide 2, which equals 1. 7 plus 3 is 10, divide 2, which equals 5. Well, hey, look at that. That's the coordinates of our midpoint. And so that is your formula right there. It's the average of your x coordinates and the average of your y coordinates. And so the midpoint formula we write like this. x1 plus x2 divide 2. y1 plus y2 divide 2. And because it's an ordered pair, we write it like an ordered pair. That is a horrible parenthesis. Right, midpoints, most kids find it easier than the distance formula because it's really just average. So essentially, whatever your x and y x coordinates are, you add them up in either order, divide it by 2. Add the y coordinates up, divide it by 2. That's the formula. It's really easy. So let's look at this. The end points of a segment are at P, which is at 3, 5, and Q is at 7, -9. So we'll say M as a midpoint. Actually, let's write it like this. Midpoint M. And we just set it up. So x1 plus x2, all divide 2, y1 plus y2. Now, I know y2 is negative, but that's fine. Divide by 2. Let's simplify. 3 plus 7 is 10. 10 divided 2 is 5. So I'm going to write it up here because I'm running out of room. 5. 5 plus negative 9. That's secretly 5 subtract 9, which is negative 4. Divide 2, negative 2. Okay, now I did that all in my head, but you can do it on the calculator. So let's see it. You can type each coordinate in as one thing. So remember, type a fraction, alpha, y equals 3 plus 7 on top, divide 2 on bottom, boom, you get 5. Typing it again, 5 plus negative 9 on top, divide 2, you get negative 2. All right, let's look at another one. So again, I'm going to set it up. X1 plus X2 divide 2. Y1 plus Y2 divide 2. All right, now I'm going to write it up here because I'm running out of room. Let's use alpha y equals on that. Let's not do it in our heads. Negative 3 plus 8. Oops, forgot the 8. Ah, sorry. Divide 2. Now notice I got 5 halves. That could happen sometimes. So let's write that out. So 5 halves. Let's do it again. 1 plus negative 5 all over 2. We got negative 2. So that is the midpoint. Okay? And a lot of times you will write it as a fraction. You can write it as a decimal if you want to. I just don't prefer that way. If you want to write as a decimal, just make sure you write the correct decimal form, though. So 5 halves would be 5 divided 2, which is 2.5. So you could write 2.5 comma negative 2 if you wanted to, but I'm not going to. Right. That's the first version of midpoint problems. The next kind of problems is I give you the midpoint and an endpoint. I want to find the other endpoint. So here's how we do that. Remember our formula. I'm going to write it back up here. X1 plus X2 divide 2, Y1 plus Y2 divide 2. That's the formula we're using. So in other words, we've already done this and we've got this as our answer. And we know, I mean, you could say this is either X1 or X2, it doesn't matter. We know one of these on top. We have to find the other one. So here's what I'd like to do. This part evaluated 3. This part evaluated to 4. So I'm going to write two equations. So 3 equals, I'm going to set 3 equal to this whole thing right here. And then for x1, I like to plug in the coordinate I had. So negative 3 plus the other one that we don't know, divide 2. The same thing with the 4 equals y1 plus y2 divide 2. Right, now we have to solve this for the x2 and the y2. So here's the easiest way you know how to do it. Multiply by the 2 on the bottom on this side and this side. And that makes those cancel out. That's going to be 6 equals negative 3 plus x2. That's an equation. We just solve it. So add 3. So 9 equals x2. Same thing over here. Times 2 times 2 That's gone. 8 equals negative 2 plus y2, add 2, 10 is y2. Now, I don't want you to leave it like that because I want the coordinates. You have to write your answer as an ordered pair. So B has the coordinates at 9, 10. And make sure you put them in the correct order. X first, then Y. All right, I'm going to do this again, but a little bit faster. So this is my midpoint coordinates. And I'm going to set it up exactly like I did over here. So the midpoint X equals X1 plus X2 divided 2. The midpoint Y equals Y1 plus Y2 all divided 2 times 2 times 2. I 8 equals 2 plus X2. Subtract 2, subtract 2. There's X2 times 2 times 2. That's going to be negative 12. Add 3. So negative 9 is at Y2. And so the endpoint N has coordinates at 6, negative 9. All right? Okay, so that's it. So remember what you've got. You've got your distance formula that I showed you where it comes from, and I need you to commit that to memory or put it down where you won't forget it. Put it somewhere where you won't forget it. You're going to have to use that all the time. You'll either be asked to do the decimal version of the answer or do the square root version. And if it's the square root version, you must simplify the square root if you can. Then we have the midpoint formula, which is really just average. You add the x's, divide it by 2, add the y's, divide it by 2. Two kinds of problems. You have both the endpoints, so like the ends of your segment, and you're trying to find the middle. Or I've given you an endpoint and a middle, and you have to find the other end. Okay? So that's it for the video lesson. Please make sure that you've watched this in its entirety before you start your homework. And if you run into any issues on your homework at all or in the notes of something confused, don't hesitate to ask for help. And that's all.